were discussing about structures, and in particular we have discussed about the way the structure is formed, and in that context we have seen that a structure can contain within itself some members can be themselves a structure, right. For example, this one member which can itself be a structure consisting of other members. This is possible, right. So, this is a structure, struct S, in which there is another struct, say P, which is a member of this. It is possible. Also, some member can be an array. This can be, say, name 10, char. That means it is a character array of name 10. Similarly, it could be some member can be int marks 20, like that it can happen. Now, so we have seen that we can have arrays within structure. Also, in the last lecture we have talked about arrays of structure. So, there is a scope of confusion between these two. That is why I want to make it clearer that there can be an array within a structure as a member, all right. So, and the other thing is we can have array of structure. So, in this case we have got an array. Every element of that array is a structure of a particular type. Right. We know that an array can hold data elements of the same type. So, if I have one particular structure defined like say student, and it can be an array of students. So, there will be each of them is of the type student. Okay. And we have also seen, so these two must be differentiated very clearly, all right. So, as you can see that here a structure member can be an array. We saw it in the last class, last lecture, that say for example, a structure student has got an array char, character array name 30, all right. This is a part of an array. Now, that we know arrays within structure. We have also seen arrays of structure where we can have a number of elements of that particular structure here. So, here we have seen that we have got an array class. The array is class which can hold up to 50 elements, and each element of this class is a structure of type student. So, individual members, when I come to say class I, then I am actually accessing a structure, a particular structure in that array, a particular structure in that array. Now, that structure has got number of fields. Therefore, if I have class I dot name, then I will get a particular name, okay, if that be the field, or I can say class 2 dot roll number. So, here I think this distinction must be very clear, that this is an array of structures and we can handle them just as here the index is pointing to the particular element, and then by the dot operator we are going inside that element and looking at that array. Whereas, in the case of an array within a structure, we can look at that in a different way. That is, if there be an, then I come to the structure student, and suppose there is a variable of name, say A1 as of type student, then I can say A1 dot say name, and I can take a particular character of that. So, look at the difference of this. This is one, the other one was class I dot maybe name j. So, here I am accessing the particular element from that structure, and here I am coming to the structure and going to that array element within that structure. So, this is an usual point of confusion among many students, that is why I was repeating this. Next, we will start looking at an important aspect, an important style of writing programs, which is type def. That facilitates our programming with structure. As the name type def implies, we are defining some type. We know that int is a type, float is a type, data type, char is a type, etc. Now, I can also define my own type that I will be using in my program using this type def statement, type def command. So, we may define a structure data type using a type def command like this. Let us see the syntax. The syntax is, I say type def struct member variable 1, member variable 2, member variable n, and then some tag. Tag is the name of the new data type. Let me illustrate this, differentiating this with the earlier thing. Say earlier we had written something like this, struct student, then char name 10, int roll number, like this. So, I was defining a structure in this way, and I was later on referring to this structure as struct student, say student 1, student 2, in this way. All right. Now, what I am trying to do here is I am trying to define a type. Suppose I don't write this, what I am doing instead, I am saying type def struct, same thing, char name 10, int roll number, and name this type as student. If I do this, then next time when I write the student, declare the student 1 and student 2, I will do it in a different way. I can do it much simply as I am writing now in the red. If I just simply write, look inside this red box, if I write student student 1 comma student 2, that is sufficient. Just as compare this with the way we had declared int x float y. So, here int and float were some types. Now, here student 1, student 2 are two variables of type student. Now, this type is not a default type, it is not predefined in C. Therefore, but I can use it because I have already using this type def statement has defined this structure as student. But please differentiate between this and the normal definition of structure student as we do normally as say struct something and then I say student. Now, this is here, is it clear? I say struct, we have seen this, and I write the members here and then define that structure as the type student. Now, this is a definition once for all a particular structure as student. Now, this if I have to use it, then I have to say struct student followed by A1, A2, student 1, student 2, whatever. But in this case, if I do this type def, I am saved from this problem. So, let us have a little look at how we will go about it. So, that is the tag. So, here type def a particular structure, just as here could be char name or int roll, just like that. Note that there is semicolon at the end of all these declarations, and ultimately I name this tag say for example here as student. So, tag is the name of the new data type. So, given that, here is an example, again the example of complex number. So, we are defining a type called complex, ignore this underscore here. So, type def something having real part and an imaginary part is known as a data type complex. And then I am saying complex ABC, just like int ABC, float ABC, I can write complex ABC because complex has already been defined here, because complex has already been defined. So, I think this is clear, right. Next, we move to how do we initialize a structure. We saw that we can initialize an array. Similarly, we can initialize a structure as well. Say a structure variables may be initialized following similar rules like an array. The values are provided in the within the second braces separated by commas. For example, here complex A. Complex A is a complex variable 1.0 comma 2.0. What does it imply? It implies that it is A is a structure having two fields and one field is 1.0, another is 2.0. Similarly, B is another field which is initialized to minus 3.0 and 4.0. Just as we did it in the case of arrays, we do it for individual structural variables, but we have to put all the values, initial values for all the fields of the array. So, this is what happened by this initialization. The other thing, that last thing that we will be talking about is parameter passing in a function. How do we pass a structure as a parameter to a function? We have seen how arrays can be passed. Similarly, how can we pass structures to a function like any other variable? Just like any other variable, we can pass it, like for example, here you can see that there is a swap between complex variable A and complex variable B. Now, A and E are both structures. So, I am just saying, just as we used to write say void swap int A int B, just like that here I write complex A complex B. Okay. It is also a call by value. Now, so here is again the typical assignment and the way we carry it out. So, here is an example program using typedef. What is being done here is I am defining a type complex, typedef struct. There are two parts, real and imaginary, and this data type is known as complex. Now, I am writing a function, swap them. So, I am taking another, I have taken another variable which is of type complex, temp is of type complex. So, when I do assign A to temp, then this temp variable which is of type complex will copy the variables, say here it was 3.0 and minus 2. So, this will come here, it will become 3.0 and this will become minus 2. So, that is temp. Now, I copy A to B. So, here sorry B to A, I am sorry, not this one. There was some B and the values of B are copied to A, not here. These are copied here and here. So, might be this is changed to 5, this is changed to 2 minus 2.5 and then I copy again B to temp, temp to B. So, this is again copied back. So, member by member the copying is done. Okay. So, here we illustrate what we mean by typedef and a function that is using it. So, now suppose how can we print a structure? Print, I am now printing the say here is a function, the main function is calling printx and print y. the main function is calling print x and print y. So, say for example, my main function is initializing, now you understand all these things, x to 4, x real part to 4, imaginary part to 5, right, and y is real part to 10 and imaginary part to 15. So, now I am calling print x. So, it is calling print x. So, x is being copied, called by value, to another local variable a, which is local to this function print. So, a is holding the complex variable x and printf a dot real, a dot imaginary. So, field by field I print them. Then I come back, I print y. Y is copied to a and the same thing happens. Then I call swap. Now, swap was a function that we just now saw, where we take temp and we copy it to temp, and then I copy b to a and then temp to a. In that way we carry out the swapping. So, it is purely called by value, and then I print x and print y. After I swap, what will happen in this case? If I go back to this case where I am passing on this a and b, the x and y are being swapped inside that function. But will that be swapped in actuality? You check that yourself. How do we return a structure from a function? Suppose I have done something, but in this earlier case x and y were being swapped inside the function, but when I come back to the main, my x y remains the same. So, if we want to return the function, for example, here I carry out a real plus b real, I make it temp. Say here is an example of adding two complex numbers. Here complex a and complex b are two variables which have been passed on as parameter here, and I have got a temp as an local function, local variable. So, temp dot real is copying a dot real plus b dot real. So, what is happening? Here I have got a structure a with a real part and an imaginary part. So, 3.0, 4.2, another is b which is 2.5 and maybe 3.6. Now, when I am adding two complex numbers, you remember we discussed it in the last class also, I first add these two. So, a real is added to b real. So, I am getting in temp, this is temp, where I am getting 5.5, and then imaginary I am getting 7.8, and now I return temp. Now, in the main function, if I had written something like say x and y were two complex variables, and what I did, I said add x y assigned to some other complex variable z. In that case, that temp, this temp will be assigned to this complex variable z. That is how we can return a structure from a function. So, structure facilitates in many ways in this. So, direct arithmetic operations are not possible with structure variables. That means, I cannot just add a and b when both of them are structures. I have to do the arithmetic operations over its members. Okay. So, with that we conclude our discussion on structures, and structure is you will be given assignments on structures, and this will enable you to write different types of handle different types of data types together, and using the type def you can design your own complex data type which you can utilize further. So, please practice using structures. It is not at all difficult, only a little practice and a little understanding is required. Thank you.